Hello my dear friends. Now in this lecture we will discussing about concept of enthalpy too. Now example number second. What is that? Example second is like that. If there is a closed system, you assume that there is a closed system and it is like that piston cylinder arrangement. There is a cylinder and this is your piston. Okay, this is your piston and this is our system. This is our system. This is your system, and if there is a electrical heating system also there, flowing current I, okay, and the potential difference V. Now if there is a, what is that? First of all, you, what is your observation? This is your heat transfer or work transfer? What is your observation? This is your heat transfer or work transfer? This is only work transfer. Why? Because charge will cross the boundary. So for that there is a electrical work, W electrical. And if the W electrical will continuously supply to the system will energize and it lose energy in the form of heat loss. Right? So what is that? Constant closed system undergoing a quasi equilibrium constant pressure process. Constant pressure process. Right? If this is our limitation, this is our limitation, and in this manner we supply work in the form of electrical work and lose some heat. During that, if the piston will move upward, right? So in a quasi-static equilibrium, and see there is a if there is a atmospheric pressure here, and this is your pressure due to piston, so the system pressure is constant, so we take a pressure constant system. Pressure constant, you may think like that. So what is your first law of PD? This is nothing, this is your energy balance. And what is the energy balance? Energy into the system minus energy out from the system is nothing, is the energy of the change in energy of the system. So what is this? What is this? This is your net energy transfer. This is your net energy transfer by which manner? Heat, work, mass. And what is this? This is your net change in energy. Net change in energy. Which type of energy? Kinetic energy, potential energy, internal energy, etc. Right? So what is that? If energy in and energy out. If we take energy in the form of heat, this is your loss, so it is negative, and this is also negative. So for that we conclude that this is your negative minus minus, this is your minus loss, that means this is your minus within bracket minus W electrical. So for that, conveniently we take the positive, and final result, if there is a negative, we put a negative also, no problem. So W is equal to what? We know that delta U plus delta KE plus delta PE, potential energy change. You know that. So if this is our zero, which condition? A stationary system. Stationary system. Okay. Now there is a heat interaction minus work interaction. It is in the form of, we take displacement of a boundary. Why? Because this is net work. This is your net heat transfer, and this is your network transfer, network transfer. So W boundary work up plus, we assume that there is other form of work. This is in transfer manner, not storage. This is a transfer. That means one is the boundary due to displacement of the piston, and there is another type of work, that means electrical work, right? Stirrer work, shaft work, like that. Okay, and this is your heat transfer is equal to what? U2 minus U1. Okay, this is 0. Why? Because stationary system. So we know that what is the boundary work. Why? Because the process is quasi-static equilibrium. This is nothing, this is your integration 1 to 2 pdv, and if pressure is constant, so pressure v2 minus v1. Why? Because pressure is constant. Okay, now what is that? It is like that. So Q minus W other form of work minus P V2 minus V1 is equal to U2 minus U1. No problem. So Q minus W other form of work, mind it, this other form of work is any type. It is not boundary work, not a thermodynamic work. This is your stirrer work. That means what is the meaning of other work? W other is not equal to boundary work. Instead of boundary work, what is that? So what is the other work? Other work, electrical work, shaft work, right? Stirrer work, like that. Okay, and what is the boundary work? Is a displacement of a boundary 1 to 2 pdv. Okay, so this other work is equal to, what is that? U2 plus P2 V2 minus U1 plus P1 V1, right? Why? Because pressure is constant, so P1 is equal to P2 is equal to P, Okay, so my dear friend, what is your conclusion? If Q minus other form of work is equal to what? And this is what? This is what? This is your H2 minus H1. Okay, so what is the physical meaning of this equation? So what is that? First of all, you tell me about what is the condition? Closed system and other constant pressure, quasi equilibrium, right? So heat transfer minus other form of work is equal to H2 minus H1. So there is disappear boundary work. So where it is boundary work? Where it is balance? The boundary work balance with change in enthalpy. That means, see the beauty. That means if you have arrangement like that, if there is a cylinder and this is your piston, you think like that, this is your piston, and if this is our system, and system will execute at a constant pressure is constant, and if we transfer heat from the system to the surrounding, there is also heat transfer Q, pressure constant, right? And other form of work, there is other form of work, this is displacement of a boundary. So you assume that there is also a boundary work, and there is other form of work transfer. That means electrical work, um, uh, shaft work, like that. So for that, what is your conclusion? There is other form of work. Mind it, paddle wheel work, electrical work. So if your electrical work like that, you have a paddle wheel work like that, journering, right, like that. So what is the enthalpy for that? Q minus W other minus W boundary. Why? Because there is a displacement of a boundary is equal to change in enthalpy, change in internal energy. First law of thermodynamics, right? Why? Because first law of thermodynamics, what is the first law of thermodynamics? Heat, net heat transfer minus net work transfer is equal to change in internal energy. So what is the net heat transfer? Q. What is the net work transfer? Other plus boundary work is equal to change in internal energy. So for that, this Q minus other form of work is equal to what is that? Delta U plus boundary work, right? And delta U plus boundary work, see, if you equate this equation to this equation, equating line. Why? Because there is a same condition is given. So if you equate like that, so what is that? What is that? This is your H2 minus H1. So what is your conclusion here? The conclusion is that heat, if the system is a closed system and process execute at a constant pressure in a quasi-static equilibrium manner, so heat transfer minus other form of work is equal to change in enthalpy. Very convenient equation, I'm telling you. So what is that? here what is that the this equation is very convenient to use in the analysis of closed system undergoing a constant pressure quasi equilibrium process. Constant pressure quasi equilibrium process. Since what is your observation here? For this equation, the boundary work is automatically taken care of by the enthalpy term. Enthalpy terms. So you don't bother about the boundary work. If you calculate the enthalpy, enthalpy itself includes the boundary work. So no longer needs to determine it separately, right? So what is that? You may remember always this type of a situation. So if this this is your cylinder and if this is your piston, right? And pressure is constant. This is our system. So for that Q minus W other minus WB is equal to delta U and WB this much minus WB and delta V together gives delta H. So for that we can write Q minus W other is equal to delta. Don't bother about the displacement. Displacement work automatically converted into enthalpy. So what is your conclusion? See my dear student, this is very important. So this is very important. What is that? What is that? For a closed system undergoing a quasi equilibrium at pressure constant process delta U plus boundary work is equal to change in enthalpy. This relation is not valid for closed system if process during which pressure does not remains constant. Pressure does not remains constant. So the boundary work itself plus internal energy, the boundary work, if there is a closed system at a constant pressure, if there is a closed system and at a constant pressure under quasi-static equilibrium process, the change in internal energy plus the displacement work exactly gives the change in enthalpy. Number first. So what is the what is the conclusion here? This is very important, I'm telling you. This is very important, I'm telling you. So what is the conclusion? So conclusion is like that. For number first, for a closed system at pressure constant, quasi equilibrium process, the change in internal energy plus boundary work is nothing, it is your change in enthalpy. And what is the boundary work? Integration 1 to 2 p dv, and here p is constant. Number first. Number second is that the change in enthalpy always gives heat transfer at pressure constant. Number third. Number third. Change in enthalpy is valid for any process because it is properties of the system, doesn't depend upon the path followed between the initial and final point. Okay. Okay, thank you very much.